So guys, my topic is internal energy, enthalpy and Joule's experiment. Let's start with the first topic, which is internal energy. Internal energy is it's defined as the total energy of the system. It's about summing up the microscopic forms of energy in a system. It comprises of kinetic energy, which arises due to molecular motion, which could be translational, rotational, or even vibrational. Second is potential energy. Potential energy is there because of the forces between the chemical bonds in the molecules, which are like van der Waals forces, dipole-dipole interactions, etc. The equation we get for internal energy is U is equal to E kinetic plus P potential. Scenarios of change. Internal energy, when in the case of heat absorption, the internal energy is tend to increase because heat is absorbed, and given that no work is done, in that case internal energy increases. Work done by system. When work is done by the system, in that case internal energy is said to be decreased. Work done on the system. If some kind of work is done on the system, like let's say increasing temperature in a piston cylinder, that increases the kinetic energy of molecules in the gas in that piston, under the piston. So in that case the internal energy again increases. Next topic. Our next topic is enthalpy. So, unlike internal energy, in enthalpy, it's more practical and it applies to a lot of chemical reactions because enthalpy is defined as the heat content in a system that is calculated under constant atmospheric pressure. The equation we have for enthalpy is H is equal to U plus PV. H is enthalpy, U is the internal energy, P is the pressure of the system, and V is the volume of system. The PV term accounts for the energy required to make room for the system by pushing against the constant external pressure. Next is delta H. The change in enthalpy is denoted as delta H. By calculating the change of energy enthalpy, we can determine the amount of heat that is absorbed or released. The equation is given as delta H is equal to delta U plus P delta V. This makes enthalpy change the most direct measure of heat of reaction in a typical laboratory settings. So there are two types of enthalpy changes, two types of reactions we'll get. In case of exothermic reactions, when the heat is given out by the system, when the heat is released, in that case the delta H is said to be negative. And when the heat is absorbed by the system, it is known as delta H is said to have positive value. The example for exothermic reaction would be burning of wood, and for the example of endothermic process, it could be of melting of ice where the heat is absorbed. So our next topic is Joule's experiment, heat and work equivalence. So in 1840s, James Prescott Joules, he did a paddle wheel experiment which consisted of a adiabatic vessel, a weight which was connected to a pulley, which was then connected to a paddle which was immersed in the adiabatic vessel which contained water. Along with that, he had a thermometer. He observed that when the weight fell, it stirred the paddles in the water. This stirring of the water, it caused a little rise of temperature. It was very small but consistent rise. This rise in the temperature, it denoted that there is a relationship between heat and work done. By this, Joules observed and established that 1 calorie of heat is equal to 4.16186 joules of work done. Work measured, it was measured as the work done by the falling weights, loss of mechanical potential energy was calculated using work is equal to force into distance. And the heat measured was the heat gained by the water was calculated from its temperature rise and specific heat capacity. This proved that the mechanical work and heat are two interchangeable forms of energy. By all these concepts, we understand that it basically builds upon the first law of thermodynamics, which says that heat energy can neither be created nor be destroyed, only transformed. Now let's summarize all these topics. Internal energy, total microscopic energy of all particles, which is given as delta U is equal to Q plus W. Enthalpy, heat content of system when pressure is constant, H is equal to U plus PV. And Joule's experiment, what we just learned, proved that the mechanical equivalence of heat is equal to 1 calorie is equal to 4.186 of joules. Empirical basis for energy heat equivalence. This entire framework of internal energy and enthalpy rests on the Joule's demonstration that heat is a form of energy and can be precisely quantified in terms of work. Alright, thank you.